Hi, so let's look at my second video from section 9.1, and this one is going to be about critical values. So let me refer to the margin of error video. When you were watching that, you found that there was this interval called the confidence interval that we were 95% confident contained P, the true proportion, the population proportion. So we are 95% confident that P is in here somewhere. P is in this interval. P hat minus 1.96, P hat Q hat divided by N, on up to P hat plus, oops, I forgot the 1.96, 1.96 square root of P hat Q hat divided by N. Close that interval there. Now this thing, the 1.96, was the critical value, Z sub alpha over 2, also known as the critical value. And it is entirely dependent on the fact that we are 95% confident. If we need to be that confident, then we need that amount of that many standard deviations above and below the sample proportion. So what if we need more confidence? What if it's really important to be accurate? Lives depend on it, or at least elections depend on it. What if we don't need to be that confident? What if we could be a little bit more relaxed and spend a little bit less money? So let's find what's the critical value associated with a particular confidence level. And that is the formal term for level of confidence that we need. Hang on, let me clear the screen. So let's go for a 99% confidence. So I need to be much more confident. Let's say we need 99%. That's bigger than 95%. So I need more confidence. And this is called the confidence level. Frequently abbreviated as capital C, capital L. Okie doke. So we use z-scores, by the way, because z-scores tell you how far above and below the mean you are in standard deviations. That's our square root of P hat times Q hat divided by N. So I'm going to have my z-score distribution here, which we know distribution is normally distributed, which is why I drew a bell curve there. Distribution is what I meant to write, distribution. And the mean of the z-scores is 0, yes. And out here are going to be my critical values. My positive critical value is the upper boundary. And this guy down here will be the same value, only it'll be negative. And the middle 99, the most common 99% of the values is going to be in the middle, because most of the values are near the mean. And so that means the area in both tails, is 1%. And that, by the way, is our significance level. So the area in just the left tail is 1% divided by 2, because normal distributions are symmetric, so it'll be an even amount on both sides. That's going to be 0.005. And this is equal to the significance level divided by 2. So that's where the fish divided by 2 comes from in our notation representing the critical value. So that's what's over here, 0.005. Now, do you remember from section 7.2, what calculator application am I going to use if I'm trying to find a value that's down here, a data value, and I know the area to the left? So, hoping you're reaching for your calculator, hoping you're looking at your distributions menu, and I'm really hoping you're picking the correct calculator application. So if you know the area, aka the probability, aka the percentage or the proportion, if you know the area under the curve and you want to find a data value, you use inverse norm. And what goes into that is area to the left, the mean, and the standard deviation. And do you remember the mean of the z-scores? Mean of all the z-scores, well, it's actually in the picture, is 0. Do you remember the standard deviation of all the z-scores? That's always going to be 1. So this will be inverse norm of the area to the left of the boundary I'm trying to find is 0.005. Ooh, I put in an extra 0 there. Sorry about that. I got a little excited. 0.005. And the mean will be 0, and the standard deviation will be 1. And that is going to provide for us negative 2.58. Now we do want the positive critical value, the positive boundary, and the reason why we want that is because we're trying to find the distance from the mean, and distances are always positive. That's going to be z sub alpha over 2. Now I don't have to do it again. Remember that because normal distributions are symmetric, and because the mean is 0, if this distance down is 2.58, then the distance up from 0 is also 2.58. So the positive z-score is critical value is going to be positive 2.58. So all I really have to do is find the negative, but just remember that I want the positive one. So that's how I'm going to find a critical value. And what did I want a critical value for again? Well, now if I wanted to find the margin of error with a 99% confidence level is going to be 2.58 times the square root of p hat times q hat divided by n. This is with a 99% confidence level. The more confident you need to be, the wider your margin of error is going to have to be. So what I'd like you to do right now is I'd like you to stop the video and work on this problem here. I want you to find the critical value, associated with, is what I meant to say. The critical value associated with a confidence level of 80%, which is not an particularly uncommon confidence level. So that is find, I'm just writing this a different way, the critical value when the confidence level equals 80%. Okie dokie. Stop the video, work on this, and then when you come back, we'll do it together. Okay, I'm ready to go. So I am always going to draw a picture. Now, I am confident that my confidence level is in the middle here because the most common values are in the middle. Always put your confidence level in the middle. And now we're trying to find the boundaries of that confidence level. So this guy over here is your positive critical value, and this guy over here is your negative critical value. Area in the tails, also known as the significance level, is 0.20. It's 1 minus 0.8. Because overall, this entire picture adds up to 1. And so our sorry, didn't want that. Half of our significance level is going to be that 0.2 divided by 2, which is going to be 0.1. So that's the area here, oops, in this tail. So I'm going to use, because I know the area and I'm trying to find the data value, I'm going to use inverse norm. And my area to the left will be 0.1, my mean will be 0, my standard deviation will be 1. And when I run that through Mr. Calculator, what I'm going to get, that doesn't look right. Hang on a second, let me check on my calculator. My notes look wrong. Okay, I've checked, and they were wrong, and so this is what I have now, negative 1.28. And don't forget, that was this guy here. So this is the negative critical value. So how about that positive critical value? That's going to be positive 1.28. Okie dokie, now please give yourself lots of practice by doing the critical value problems in the 9.1 homework. This has multiple steps to it, and once you get familiarity with it, it'll come naturally. Without the familiarity, you'll be stumbling over it every single time. So please do your homework on this as soon as you can. Thanks for watching, and I'll see you in the next video.